All right, we're going to go over question 1 from the week 6 assignment. We're not actually going to go over this exact question. We're going to go over an example from the textbook. Before we go over that problem and start working on that problem, just to note that this problem, question 1, is actually coming from, it's more of a question from section 4.3. And week 6 goes over section 4.4 and 4.5. So this is slightly misplaced, but it's okay because you covered 4.3 in the previous week. But I just wanted to let you know that the material to understand how to do this problem comes from the previous week. The problem that we're actually going to go over is from your textbook that we're going to mainly go over right now. And this comes from section 4.3, example 4.19 on page 182 of your textbook. And it's covering testing hypotheses using confidence intervals. And you're able to test hypothesis tests, and this is the setup for a hypothesis test right here. You're able to test two-tail tests, like this is right here, a two-tail test since it's not equal in the alternative hypothesis. You're able to test something like this with the confidence interval. And that's what they're kind of suggesting in this problem, because you'll notice that there, I don't actually have it here, but for the solution, there's two blanks. There's a smaller and larger value for the mean, for the sample mean. So that's essentially saying build a confidence interval, and there's a lower and the smaller and a larger value for the two ends of your interval, for your confidence interval. And so anyways, that's why we're going to go over example 4.19 on page 182. So on example 4.19, so I'll just write 4.19 on page 182. They give us x bar equals 2.78. They give us standard deviation. Standard deviation is equal to 2.56. They give you that in the problem. They give you n. N is equal to 100. They give you 90, or they give you z star, which is the critical value, which is 1.96. And they give you one other value, which is the confidence level. So the confidence, I'll just put CL, is equal to 95%. Okay, so, that's essentially what this is saying right here. The p-value is equal to 0.05. That is saying, you know, what the difference between 100% and the confidence level is essentially saying, you know, the p-value or alpha. In how they're constructing this problem, a p-value is they're treating it like an alpha, the level of confidence. So 0.05 is the difference between 95% and 100%. In decimal form, it's 0.05 or 5%. So we're going to have the same confidence level for each of these, just to show you the parallel. Okay, so all right, so some of the calculations that they did, they have the standard error is equal to s over the square root of n. That's the formula you may be familiar with, that you've seen. That equals 2.56 over the square root of 100. Good. Which equals 0.256 after you simplify. And they ended up determining the let's see here. Okay, so they have the result of the confidence interval, 2.27 to 3.29. And this interval right here, this is the confidence interval. This kind of represents our solution. for our question 1. Our smaller and larger value of your confidence interval represents our solution. So we're going to see how to calculate this. They do a lot of this by hand in example 4.19, and they don't explain every little detail. So I'm just going to show you how to get this result really quickly with your calculator. It's pretty simple. So this is the confidence interval, and this is a Z. Notice that they're using Z star, so this is a Z confidence interval. So we'll go into our calculator, and we'll go to Stat, over to Tests, and we're looking for Z interval. Oh, right there. So Z interval, and we do not, so there's the option of data or stats. So we do not want data. Data is if you have raw data, individual data values. We don't have that. We have the statistics, like the, so X bar, S, N, and so forth. We have these statistics. Okay. So we're going to use the statistics, not the data. Because if you had data, notice that you would be inputting your list because you would have your data, your actual individual data values that you input. So we'll go back to stats. All right, so there's a little bit of information that we want to kind of just I'll just acknowledge. We're going to be treating our S, our sample standard deviation, as our sigma. Sigma right there. That is our population standard deviation. Because it varies between textbooks, but it really doesn't make much of a difference here. But some textbooks, you only use Z interval if you're given sigma and not S. But in this textbook, since we're using Z star, not T star, we're going to be using Z interval instead of T interval. So we'll just treat this as this is like our sigma here. And we'll actually notice something. We don't actually need to use that value 1.96. We won't be inputting that. We'll only be inputting our sigma, or our sample standard deviation, 2.56. Sigma is population standard deviation, but we're treating it that way. X bar is 2.78. And our sample size, and that's 100. So hopefully you see that. And our confidence level is our C level, and we'll input that in decimal form, 0.95. And we're ready to calculate. That's it. We don't need to know any other process. The calculator does everything for you. All right, and we can see how we got this result here. It looks like there's some slight rounding error. Not a big deal. But we essentially got the same exact result. So yeah, so the calculator gave us 2.2782 and 3.2818. The little off, it's just some rounding error. I imagine it's the rounding error that they actually did in the textbook, because Z star, they use Z star as 1.96, and we'll actually notice that Z star is not exactly 1.96. I'll show you really quickly. You can actually use your calculator to calculate this. It is due to rounding error. Go to distribution and do, let's do, inverse norm and 0.025. You don't exactly need to know how to do this, but it's, well, there's some rounding error here. It's not that far off, but that is probably where this little bit of an error came from. Anyways, that's how you use your calculator to find this result. And now comparing this to the problem here, we'll notice that that we want to be centered. You'll notice that our value right here, X bar, is at the center of this value right here, of our interval. So X bar is directly in between or 2.78 is directly in between these two values. You can check that. But we want 30, the value 30, to be in the center. So we want to treat this as our x bar. And then you're also given standard deviation. And standard deviation is 10. So that was another piece of information we had in the problem. And we also have our sample size, n equals 70. And p-value equals 0.05. As mentioned before, that's equivalent to a confidence level of 0.95, 95%, 0.95. Okay, so that's how you would approach this. I'll let you figure out the rest. Let me know if you have any concerns about this process. Anyways, yeah, good luck.